looking through some problems. The first one is pretty straightforward. We're given a center circle, as the center of a circle. It's got a radius of 7. Our angle that we want to look at is 2 radians. So an arc PQ that's subtended by 2 radians, we just substitute in the 7 and the 2 into the length of the arc formula, gives us 14. Remember, 2 is going to be in terms of radians, so we need it to be in terms of radians there. So we've already given it, so it's not too much of a problem. Area of sector PAQ this time, we'll be using the half r squared times theta formula. Again, so it's straight substitution of 7 and 2. Calculate it to 49 centimetres. Pretty simple, just applying the formulas. The next one though, we've got 47 degrees at the centre. So our angle there is a problem because we can't have an application where it's in degrees. We need it to be in radians. So we change our angle to radians. Multiplying by pi on 180, get an approximation. Really, we're saying 3 significant figures at the moment, but we're not really worried too much about it. Much more than we can just get our angle by doing that conversion. Our radius is 10. 10 times the 8.82 gives us 8.20 centimetres. So there's our length of our arc. The area of the sector, again, we're applying half r squared and theta. Theta is going to be in radians. We can't have the 47, it'll give us an error. Comes out to approximately 41.0 centimetres. Remember, that's going to be an approximation because pi is irrational. So if the next one, we got calculating degrees and minutes, the magnitude of an angle subtended by the center of the circle. This time we've got to work out the angle. So we're given the length, radius is 8 and the arc is 15. So if you apply that, we get that theta would be equal to 15 on 8 or 1.875. But it wants us to give us our magnitude of the angle in degrees and minutes. So we need to convert it back to degrees from the radians we've got, and then get 107 degrees and 26 minutes when we do that conversion, just using the calculator. In question 4, again we've got angle of 100 at the center, and the radius length is 12. Calculate the arc length in terms of pi. So again, this time we're just going to make sure we leave it in terms of 5 pi on 9, not in terms of a irrational number. And our arc length times our angle, 5/9 of 12 gives us 20/3. Leave it in terms of pi, and we've got our answer to our question.